Hi guys, thank you so much for joining me and continuing to join me on this Club College Algebra video series. And I just want to say that I am proud and I'm very encouraged that you are doing this and that you are now at 2.4. We'll be solving systems of equations today. So let's go ahead and look at it and see what's going on with this thing called systems of equations. Okay, system of equation is two or more equations. Okay, so for example, system of equation, we're specifically going to be dealing with two equations because if it's more than two, there are better ways to solve them. But for two equations, we are going to be dealing with the systems of two equations. Here are the methods that I'm going to teach you today. We're going to be solving this using elimination method. We are also going to be checking out the substitution method. Substitution method. Okay, we will be looking at solving this graphically, okay, graph method, but we will do that another time. Okay, so not now. We will do that once we learn how to graph linear systems or linear equations, then we'll talk about how to solve linear systems by graphing. Okay, so let's look. We're actually going to be working with specific problems. So let's go ahead and go to those problems that we will be solving. Okay, solving systems of equation by elimination. First, I want to show you the motivation for them. Okay, so how can you look at this and going to work on elimination, and we're all going to learn this by examples. So we're going to look at examples and figure out what's the best method just by looking at it. Okay, so right now we're going to deal with elimination. Elimination. Okay, elimination, just like the word eliminate means, is you want to eliminate one variable. When you have two variables, you need two equations to be able to solve um, to be able to figure out the value of each variable. So with elimination, what you want to do is to eliminate. Try to cross out one variable. Okay, so let's look at number one. Notice I'm going to rewrite number one so that they are right. They are exactly on top of each other. So, so you have -3, -3x plus 7y equals 28, and then 3x plus y is equal to 4. Okay, you notice the elimination. Usually when you see that you have the variables aligning, so look at all the x, all the y, all the numbers. So it's almost like we made it so that all the variables align. So when you see something like that, elimination will probably be the easiest method. So you want to use the method that is the easiest. Now, you want to look at it and you try to see, okay, can I cancel a variable? Well, notice how -3 plus 3 will give you 0. So that's good. You can eliminate the x's. So what you can do here is you can put this together. You can add the equations together so that you can eliminate one of the variables. Specifically, here is the x. So -3 +3 crosses out and becomes 0, which is great because now you just have a one variable equation. So you're putting this together. 7y plus y is 8y equals 28 plus 4 is 32. And you can solve this. This is just an equation with one variable. Divide both sides by 8. So your variable y is equal to 4. So here we found y. Okay, so this should say solve for x and y. Okay, so y is 4. Now to get the x, all you do is pick one of the equations. Doesn't matter which one you pick, but of course you want to pick the one that's easiest for you. So I'm going to pick the second equation, and then I'm going to plug in y and solve for x. Okay, so I have 3 positive 3x. Instead of y, I'm going to substitute the 4. Okay, so I got 4 here. So now I know what y is. Y equals 4. So instead of y, I'm going to put 4, positive 4. 3x plus 4 equals 4. Now I need to solve for x. Subtract 4 on both sides. 3x equals 0. Divide both sides by 3. So my variable x is obviously, let's find it. Okay. So my variable x is obviously equal to 0. Okay. So x is equal to 0. So y is 4, x is 0. This is an ordered pair. Y is 4, x is 0. X is 0, y is 4. Okay, so what we're actually doing here is these things are two lines. They're not going to be accurate. They're not going to be accurate, of course, because I don't have a grid and I'm not trying to make them accurate. But these are two lines. Yeah, I don't mean it. These are two lines that are crossing at some point, at 1.04. Okay, so 0, 4, wherever that is, these two lines are crossing. Again, this is not an accurate graph. I'm just trying to give you a visual of what it means to solve. It's like where did the two lines cross? Okay, so that's on number 2. Quickly, can you see now where -9, +9, those are same and opposite, so you can eliminate them, and you have -1x is equal to -3. Divide both sides by -1. So your variable is equal to +3, your variable x. Now pick one. So I'm going to pick the first one. 8x plus 9y equals 24. Substitute 3 into the x. So at 8, wherever you see x, replace it with 3. Okay. Plus 9y equals 24. 24 plus 9y equals 24. Just subtract 24 on both sides. So I'm going to finish it up right here. Subtract 24 on both sides. This crosses out. 9y equals 0. So y equals 0 because 0 divided by 9 is 0. It is not always the case that one of the variables is 0. It just happens to be like that for these problems. Okay, so it doesn't always end up with the variable, one of the variable equals 0. Okay, so to step for elimination, you want to do elimination if they line up. So you want to do elimination if everything lines up. Everything line up. Okay, that is what gives you the clue. Okay, if everything, the x's line up, the y's line up, the numbers line up, maybe elimination would be the best way for me to do this. And elimination is you want to cross out, you need equal and opposite for one variable. You want to eliminate equal and opposite variable, and then you want to solve. Okay, so line up, one equal and opposite value, eliminate equal and opposite value, and you solve. Okay, so let's look at the next one. Okay, next problem. Okay, now look at number 3. Notice on number 3, the variables line up. X line up, Y, then number. Okay? But now we have one that's equal. We have one that's equal, but we don't have them to be opposite. So it's easy to solve that problem. If you don't have them opposite, but you have them equal, all you have to do is take one of them and multiply it by a -1. And all a -1 does is it changes the sign. So I'm going to rewrite this first one, multiply everything by a negative. So that just changes the sign. So everything's sign changes. 5x minus 9y equals 13. Okay, so I multiplied it by a negative because I wanted the 9y's to be opposite signs. So now I'm going to work with this and the new equation. So this is the one that I changed. I'm going to put a line so that you don't get confused. Okay, so now we can combine these two. Combine these two. Okay, 6x plus 5x is 11x. We can eliminate this because it becomes 0. And negative 24 plus 13 is negative 11. Finish it up. Divide both sides by 11. So your variable x equals -1. Okay, so we found x. We need to find y. Okay, so to find y, again, pick any of your 2 original problems. Now, you can use your new equation, but I like to use the original equation just in case there's any little mistake. So I'm going to use the second one. 6x plus 9y, 6x plus 9y equals -24. I'm going to substitute -1 into the x, so 6 instead of x, I'm going to put -1. Instead of x, I'm going to use -1, okay, plus 9y, and add 6 to both sides. Add 6 to both sides, plus 6, plus 6. Okay, so 9y positive is equal to -18. So your variable y is equal to -2. So you have the 2 numbers are -1 and -2. Okay, so if you look at number 7, okay, we're going to skip to number 7. We notice that x is lined up, y is lined up, number is lined up. But now you notice that you don't have a variable where you have same number, different signs. Okay, so for elimination, what you want to look for is same number, different signs, because you want to be able to eliminate that variable. And if you have same number, different signs, you can eliminate it. Like 5 minus 5 is 0, -5 plus 5 is 0. Okay, so when you do that, when you don't have that, you have a choice. You get to choose which one you think would be easiest for you to eliminate. Okay, so here I can choose whatever I like. I'm going to stick with my positives. Okay, so I want to be able to multiply, find the least common multiple for 9 and 2. And it turns out I can make both of them 18. Okay, and I also need to make them different signs. So I'm going to multiply the second one by -9 to make it -18. And I'm going to multiply the first one by -2 to make it -18. You have to multiply that number on every single thing in the equation. Okay, so on the first one, 2 times 9 is 18. That's what we want. X. 2 times -3y is -6y. Okay, and 2 times -24 is -48. On the second one, 9 times a positive -9 times a positive 2x is -18x. That's what we want. -9 times a -4 is a positive 36y. Okay, and then -9 times a -12 is equal to a positive 108. 108 positive. Okay, so now we have them to have the same signs and the same numbers and opposite signs. So now we can combine. Okay, so 18 and negative 18 becomes 0 and crosses out. Negative 6 plus 36 is 30y. Okay, and negative 48 plus 10. Well, here's a 0 and here's a 6, so it turns out it's a 60. Now solve it, divide both sides by 30. Okay, equals 60. So your variable y is equal to 2. Okay, so question. What if you decided to eliminate the y and multiply and try to get them to be 12 and negative 12? That's perfectly okay. Doesn't matter which variable you eliminate first. Okay, now take what you got and go ahead and plug into the equation of your choice. I'm going to choose the second one. 2x minus 4y equals 12, negative. Okay, plugging 2 for y. 2x minus 4 times 2 equals negative 12. Okay, so plugging 2 for y. And then solve it. 2x. 2x minus 8 equals negative 12. Add 8 to both sides. So your variable 2x, this goes away, equals negative 4. Divide both sides by 2. So your variable x is equal to negative 2. Okay, so when x is negative 2, y is 2, and this is where the graph intersect each other. That's where they cross. That's the value that they have in common. Okay, again, elimination. Align x, align y, align numbers. If they're aligned like this, then elimination is probably the easiest to do. Okay, so once you align them, then you try to do whatever you can to have same sign, same number, different signs, so that you can eliminate one variable and then plug in your answer to get the second one. Okay, so I'm not going to do number 8 with you. You can do that one on your own. And I just did number 7. Let's kind of track back. Okay, so finally, let's go ahead and look at the substitution method. Okay, so substitution method. You want to do substitution if one variable is solved. So, like, for example, right here, you have y equals 5x. So one variable is solved, it is by itself. So what you're going to do with substitution method is that you are going to substitute. So y equals 5x. So it tells you, it gives you what y equals, 5x. So substitution means plug in. So wherever you see y in one equation, you're going to replace with 5x from the second equation. So I will rewrite the first equation, but wherever I see y, I am going to replace it with a 5x. Okay, so wherever I see y, I will be replacing with what y represents. Y is equal to 5x. Okay, so now that I did that, notice now I have a one variable equation. I can solve a one variable equation. 4 times 5 is negative 20x. 2x equals 0. It all comes together. 2x minus 20x is negative 18x equals 0. Therefore, when we divide by negative 18, our variable x is equal to 0. Okay, 0 divided by anything is 0. And then you can plug into y. Y equals 5x. Y equals 5 times 0. Therefore, y equals 0. So x is 0, y is 0. And we can visually check this real quick. 2 times 0 is 0, minus 4 times 0 is 0. 0 minus 0 equals 0. Cool. 0 equals 5 times 0. 0 equals 0. So 0, 0 is our answer. So these two lines intersect, cross each other at the points, at the origin, 0, 0. Alright, so here is another one where we can substitute. Notice y equals a number. It doesn't always have to be y equals. It could. Alright, so This is a good substitution problem because y is equal to negative 2x plus 17. One variable is solved. Okay, so y equals negative 2x plus 17. So that tells me whenever I have y on the other equation, I'm going to replace it with what it is. Substitute. Okay, so negative x plus 3. Okay, instead of y, I'm going to substitute negative 2x plus 17. Okay, equals negative 5. Now I would like to distribute. So 3 times negative 2 is negative 6x. 3 times 17 should be positive 51. Okay, and I bring the negative x down, equals negative 5. Alright, so step 2, combine like terms. X and negative 6x is negative 7x plus 51 is equal to negative 5. Okay, add 51 to both sides. Okay, so that you have negative 7x is equal to 51 minus 5 looks like we have 45. Okay, divide both sides. Okay, and then you subtract 51. First, you combine like terms. Negative x minus 6x is negative 7x, and plus 51 is equal to negative 5. Subtract 51 on both sides. Minus 51 minus 51. So negative 7x, we bring it down, equals negative 56. And then you want to divide both sides by negative 7. So your variable x is equal to positive 8. Okay, you gotta find your y. You can choose which equation to plug it into. But as you can see, y is solved by itself, so that would be the easiest equation to plug it into. So that's what I'm going to choose, because why make it harder for myself than I have to? So instead of x, I'm going to put 8 positive. Okay, and then I'm going to solve. Negative 2 times 8 is negative 16 plus 17 gives me 1 for my y. So the ordered pair is 8. 1. X value is 8, Y value is 1. Okay, we're gonna stop right there. Thank you so much for your time.